Hello, I am Tayfun Yörük from Akdeniz University in Antalya, Turkey, and today we are going to talk about brake systems and elements. Brake elements are, as you see in the picture, brake pedal here, a master brake cylinder, and hydraulic pipes, which is shown here, steel pipe, and wheel cylinders on 4 parts, and limiter and the dispersion block or disintegration block here. When we talk about brake pedal, firstly, we can say that when the brake pedal is depressed, master brake cylinder turn this force into hydraulic pressure. Brake pedal works according to principle of lever. Here you can see the lever. Little force applied to pedal is transferred to brake master cylinder as a great force. And the second part of the brake system is master brake cylinder. And the driver applies the force to brake pedal, but this force is not enough to create efficient braking pressure in the hydraulic brake system. So the force has to be increased. Vacuum helps to increase of the force. And the third part is hydraulic pipes, steel pipe. Here you can see. Hydraulic pipes are the ones which are used to transfer the hydraulic that comes from the brake pedal system to wheel mechanisms on 4 parts. When we look at the wheel cylinders, there are 4 wheel cylinders, which one is front left, front right, back left, and back right. Wheel cylinders transfer the pressure in the master brake system to brake shoe as a mechanical force, and it provides braking by opening brake shoe to drum brake. And limiter, here we cannot see the limiter photo, but in the moment of braking, some load transfer occurs from backside to 4 part of the car, and the center of gravity shifts 4 parts. So the load that shifts the front wheel becomes more than the load that shifts back wheel. It shows that back wheel needs much braking. If no adjustments are made, the same amount of braking pressures will send to front wheel and back wheel. The back wheel will be locked and the car will start to slip. When the car starts to slip, backside shows skidding tendency. To prevent this, the hydraulic that goes backside should be reduced. To fulfilling this function, limiter is used in the conventional dispersed braking system, and compensator is used in the kitty corner dispersed braking system. When we look at the disintegration block or dispersion block, it delivers the pressure hydraulic that comes from master cylinder evenly to wheel cylinders. By this way, the car provides handling in the moment of braking. If we talk about the overall structure and the working of the brake system, we can say that hydraulic braking system consists of 3 parts: control drive, hydraulic drive, and braking wheel mechanism. Control drive is the mechanism from braking pedal to central cylinder, and hydraulic drive is the system that transfers the mechanic force to wheel cylinders by turning into hydraulic pressure. Braking wheel mechanism is mechanism that provides braking by converting hydraulic pressure into mechanic force. Counter force that applied to braking pedal during braking creates repelling force in pedal. This action pushes the piston of the master cylinder. Repelling force on the piston pushes the brake to the wheel cylinders by means of liquid at the system. Braking wheel cylinders transmits hydraulic pressure to brake shoe. Shoes is brake wheel mechanism opens towards drum brake, and this makes a friction between lining and pulley. With the effect of retarding of the frictional force, wheels run down and the car is braked. The hydrovac intake manifold vacuum that happened in the car engine during the braking will form an extra force in addition to foot force. Handbrake is also called as parking brake. Handbrake is used by pulling with the hand by the driver, and it affects at least 2 wheels of the car in a mechanical way. To anchor safely when the vehicle stopped, driver should pull handbrake hardly or press an addition pedal in the foot section. Lately, this brake is used in front wheels and drum brakes are used in the back wheels, but it's common to use disc brake in 4 wheels. This brake system consists of yoke stable and brake pads placed in this yoke with brake shoes, brake hydraulic cylinder, and pistons. If we talk about electromechanical parking brakes, we can say that to anchor safely when the vehicle stops, the driver should pull handbrake hardly or depress an additional pedal in the foot section. Nowadays, with developing technology, handbrake is provided more safely and freely by pushing shortly to a key that in front of both. Electromechanic park brake provides anchoring, standing, braking safely, and necessary resistance while driving on slope. When it's pushed to parking brake button, a signal is sent to gearbox which connected to yoke by the control unity, and the engine starts. The motion from engine is transferred to gearbox by means of a spin. Gearbox spindle and the cylinder moves forward by turning. This squeezes linings by pushing wheel cylinder pistons to linings. If you talk about anti-lock braking system, ABS, which in short, we can say that it's easy for the vehicle to slip in a wet or slippery floor. Putting the brakes in place immediately locks wheels and make them slip. Not only vehicle carries ongoing, but also course balance and direction control is over. In this case, the vehicle's brakes should not be pumped continuously. The brakes should be pumped intermittently. So balance can be under control and driver will not lose steering control. But in this case, your stopping distance increases too much. Anti-lock braking system's duty is to prevent locking wheels during powerful braking. In other words, before the wheels slip, it should be braked till locking. This should be done in the highways which are dry or ice slippery. ABS control unit prevents wheels get blocked by evaluating information that got from wheel speed sensor. It's done by increasing and decreasing the hydraulic pressure of the blocked level. Traction control system is another part. ACR, TRC, TC, or TCS, which in short forms. Traction control systems theory is compromised with ABS system. Basically, friction ratio is base parameter in both systems. They both prevent wheel from slipping on the road. They do it by holding the linear force between road and wheel in the level which friction lets. During braking, this force happens forward way, and the slipping during this moment means blocking the wheel. Main duty of the traction control system is to prevent from spinning by doing engine torque controlling along with driving wheel brakes. ESP, which is short and the long term, is electronic stability program. The duty of the electronic stability program is to prevent from an unexpected results in a slippery situation by cutting in when required. In other words, it's for preventing the vehicle from getting out of control by slipping in sharp bends or immediate steering wheel movements while trying to escape from something or object immediately. ESP system always controls vehicle against lateral force. ESP system provides this task by means of gas throttle and applying braking into four wheels. Electronic brake force distribution, EBD. Main duty of EBD is to distribute braking force between front wheel and back wheel in a balanced way. Nowadays, engine and gearbox systems are in front of the most vehicles, so there is more loading in the front of the vehicle. In vehicles that have classic braking system and not having ABS and EBD system, the braking force will be distributed to the front and back wheels equally. As a consequence of this, in heavy brakings, braking force will be too much and there will be aquaplaning in heavy brakings. Braking force will be too much and there will be aquaplaning in the back wheels. At this moment, ABD comes into play and change the distribution of braking and provide less brake force to back wheels. By doing so, it prevents retarding aquaplaning locking as much as possible.